Hey everybody, we are still in section 2.2. We're going to talk about the examples. The first thing we're going to do here is rewrite these statements in if-then form. It says rewrite the conditional statement in if-then form. So the first statement is all birds have feathers. If I wanted to write that in an if-then form, I would write something like this. If it is a bird, then it has feathers. And if I go back to my highlighting technique of highlighting the hypothesis in bright yellow, we know that the hypothesis comes after the word if, and then the conclusion in bright orange, it comes after the word then. So if it is a bird, then it has feathers. That's part A. Let's look at part B. Part B says two angles are supplementary if they are a linear pair. Two angles are supplementary if they are a linear pair. So what that tells me, I know it might seem like you want to change it around. So I hope that that instinct is in you, because that's what we should do. If you have a linear pair, then those two angles are supplementary. So again, the if-then form of this is if angles are a linear pair, if your angles form a linear pair, I could have said that better, but we'll get over it, then they are supplementary. And that's how we want to do that when we rewrite our if-then statements. Let's go on to example 2. So in this case, we are going to rewrite this statement as an if-then statement. That's going to be our conditional statement. And then after that, we're going to take that information and we're going to write the converse, the inverse, and the contrapositive. So let's go ahead and take a moment to rewrite that as an if-then statement. So here we have, if you play the guitar, then you are a musician. And our hypothesis is you play guitar, and our conclusion is you are a musician. And I think we would agree that that's pretty true. If you play an instrument like guitar, then you are a musician. And so that is our conditional statement. Let's go ahead and figure out what our converse is. So when we're dealing with the converse, right, you are going to literally take the hypothesis and switch it with the conclusion. So instead of having if you play guitar, you're going to say if you are a musician. So that's the conclusion that we had before. And now our hypothesis will be the conclusion. Then you play the guitar. Okay? So with that, sorry for the sloppiness, but with that, we see that this is not true. It's actually false. If you're a musician, you don't necessarily play the guitar. So we are going to say that that's false. The inverse is also going to be related to the original conditional statement, but what we do is we just negate both of these. So we say the opposite of this. If you don't play the guitar, then you are not a musician. So if you don't play the guitar, then you are not a musician. You can clearly see that that's false. You can play something else, right? And then finally, the contrapositive is when we switch these two around from the inverse. Basically, if we go back to the conditional statement, we negate both of these and then we switch them. So it will read, if you are not a musician, then you do not play the guitar. Again, if you are not a musician, then you do not play the guitar. That sounds pretty true. If you don't play music at all, then you definitely don't play the guitar if you're not a musician. So these are the things that we've been talking about in class. I hope they make sense, and I hope you could have done this example by yourself. Let's go ahead to this third one. So we're looking at example 3, and we're going to decide whether each statement about the diagram is true. And what we're going to do is we're going to use definitions to do so. So the definition of a perpendicular lines is that there are two lines that intersect to form a right angle. So I go over here and I look and I say, hey, AC and BD do intersect to form this right angle. They are indeed perpendicular. So that statement is true by the definition of perpendicular. Let's go ahead and look at another definition for this next one. What are linear pairs? Let's think about it. We remember that linear pairs are two angles that are adjacent to one another, right? They share the same side. They're adjacent and they form a straight line and they're supplementary. So with that in mind, I'm going to check this one out. Does angle AEB and angle CEB have those qualities? Are they adjacent? Yes, they share a ray. And do they form a straight line? Yeah, they do. They are supplementary. Therefore, they are a linear pair by definition. We're going to do the same thing with this last one. We see ray EA. Let me go ahead and get a highlighter so I can focus you in on it. Ray EA is from here to here, right? And ray EB is from here to here. And we're asked, are they opposite rays? Well, they do start at the same point as opposite rays do, but they don't go in either direction such that they form a straight line. This clearly forms a 90-degree angle. So the answer here for this one is no. By definition, this doesn't work. So what we did is we used definitions here to clarify. We use these little if-then statements that we have as definitions to clarify a situation. The final example that we're going to do together is example 4. You are responsible for trying this one and this one by yourself, okay? So we're going to do this one, which says write the definition of perpendicular lines as a biconditional statement. Well, let's go back to what that definition is. So we're going to start off with the definition. Again, if two lines intersect to form a right angle, then those two lines are perpendicular. And you remember that biconditional statements are statements where the statement is true and the converse is true. Do you remember what the converse would be here? So the converse is when we take the two what is it called? The hypothesis and the conclusion, and we switch it. And so we're going to do that right now. If two lines are perpendicular, then the two lines intersect to form a right angle. So how do we write this then as a biconditional statement? Here's how it looks. Two lines are perpendicular if and only if the lines intersect to form a right angle. Now that we've gotten that out of the way and you've copied this information down, take a moment to do these problems here, these last couple, and I'll be checking them tomorrow and looking forward to seeing you have it all completed. I look forward to talking to you guys soon. Take it easy. Bye-bye.